Now, for vectors, yesterday I briefly started scalars and vectors, right? Now, for scalars, we only have magnitude, that means the size. Okay? For vectors, we not only have magnitude, we must also have what? Direction. That is the only difference. Everybody clear? For example, I just gave the same example. Ali traveled 30 kilometers. This 30 kilometers is a scalar because it's just a number. Understand? Okay? But if I say Ali traveled 30 kilometers north, that means it goes upwards, right? Correct. Then this one will become a vector. Everybody clear? Okay, so scalar only has got magnitude, but vector has got magnitude as well as what? Direction. That's all. Everybody clear? Okay, good. Now, representation of vector. Now, vector is represented this way. It's a line segment with an arrow. Okay? Now, it can be P, Q. Then this vector, you will write PQ with an arrow on top. That means it's from P to what? Q. That's a direction. Okay? And in your textbook, vectors are bold. That means they write A in bold letters, right? But when we write, we cannot bold it, right? So you must put a tweeter below. A tweeter, B tweeter, C tweeter. This will mean vector. If you only write A, B, C, they just mean constants. That means they are numbers. Everybody clear? Okay? You don't go and say, oh, I bold it. No such thing, okay? Understand? We must see the tweeter below. Now sometimes I write too fast and the tweeter will just become a line. It's fine. You understand what I'm talking about? As long as you differentiate it. Everybody clear? Without the tweeter, we will take it as it's a number. It's a constant. It's not a vector at all. Okay? So are we clear the notation first? Okay, now let's take a look at page 166. A vector can be represented by a directed line segment where the direction of the line segment is that of the vector and the length of the line segment represents the magnitude of the vector. Okay? Alright. Now, for example, I have this PQ. Okay? When I put PQ, it represents the vector from P to Q. Now, what if I put two lines here? That means I want the length, the magnitude. That means how long it is. Okay? So once I put this, it means magnitude. Everybody clear? Now, if I represent it by A, I can also say this. What do you mean by this? The magnitude of what? A. Do you understand? I'm showing you the equivalent so that you can identify. Be it this way, they are also referring to magnitude. What does magnitude mean? How long this is? It doesn't involve direction. How long only? That's all. Okay? Alright, now, that means this one is actually a number, right? Because if it's about magnitude, it's about a number only, right? The number got no direction, understand? It's just the size. Everybody clear? Okay, now let's take a look now. In figure 5.2a, the displacement vector is denoted by PQ, where P is the starting or initial point and Q is the ending or terminal point. The magnitude of PQ is denoted by, can you see that two stroke by the side? Okay, and they tell you that two stroke is actually 100 meters. That means the length is 100 meters. Okay, now next. In figure 5.2b, another way to denote the vector xy is A. And the magnitude is, can you see the two lines then A? Okay. When we write, we cannot bold the letter, so we write it as tweeter. Can you see? Exactly what I'm saying. Everybody clear about the notation first. If you're not clear, then you'll be in trouble. Everybody okay? Alright, good. Then we are going to carry on. Vectors on Cartesian plane. Okay? We can move P to Q by moving 4 units in the positive X direction and 3 units in the positive Y direction. So another way to describe PQ is to denote by the column vector PQ43. This one is something, that's why you must do matrices before this. Then you understand what it means, okay? Now, vectors are always represented by column matrices, so-called, and they call it column vectors. Okay, for example, I have PQ as 4, 3. What does it mean, right? What is this nonsense talking about, right? Okay, PQ as 4, 3. Now, this means this, the initial point is P, okay? I want everybody to look here, I don't need to copy. This one is what intuition, you know what? 4 units, right? 4 units, 3 units. 4. 1, 2, 3, 4. You move 4 units to the right. Then you move 3 units what? Up. 1, 2, 3. So your Q will be here. That's why I give you the square paper for you to count. You understand? Okay. Now then I want to ask. What does this mean? I start with X, right? Then I move 4 place where? This side. 1, 2, 3, 4. Then 3 place up. That means your Y will be here, and you must put the arrow here. From where to where? Everybody clear? Okay, now then I want to ask another question. What does this mean? Just like that. No going up, no going down. If I flip it, what does it mean? It means just go up. No left, right. Everybody clear? Now what if I have this side 10, this side 4. Then you will join. You understand what I'm talking about now? So the first one is always the horizontal direction or the X direction. The second one is the vertical direction. Then you tell me where does it start? It doesn't matter, just start from one square. You start. It's just a column vector representing it. Because every vector, right? Let's say I have another vector that is parallel to PQ. Let's say I have XY parallel to PQ. This XY will also be 4, 3, you know. If they are of the same length. You understand? Because it represents 4 units and 3 units. So it doesn't matter whether you start from the origin or not. That's why the text is very funny. It doesn't matter. Only when we come to position vector then it matters at the last part. Understand? Okay, you don't have to worry about that. You just know that you start from somewhere carry. Everybody clear? Okay, good. Now, next okay. You look at page 167. Okay? Now, how do you find the magnitude of a vector? Okay? How would you find the magnitude of a vector? For example, I give you the vector A as x, right? The magnitude of A, right, will be x squared plus y squared. Can you see it looks like Pythagoras theorem? Can you see it looks like Pythagoras theorem? Okay. For example, I have PQ as 4, 3. Then what is the magnitude of PQ? 4 squared plus 3 squared. So this will be 5 units. Are we clear? Are we clear? Can or cannot? Can or cannot? Can, Okay. Now, I want all of you to look at the practice now. I seldom do practice now, but I want you to look at the practice now. Can I have the visualizer set up? So that you all can see it better. Can I have the visualizer set up first? Okay. So, I want you to look at the try it or practice now. Can you look at it? How do we write those in column vectors? How do we write those in column vectors? Okay, I'm going to show you data. Okay. you some time, you don't worry first, okay? Thank you. Closing. Okay. Now, actually, there is no need for the x and y axis. It's okay one. Now, how would I represent AB as a column vector? That means you start from A. So, 1, 2, 3, right? If we want negative 3, then 1, 2, 3, 4, right? Negative 3, 4. That will be your column vector that represents AB. Okay? Now, I don't want to find its magnitude. When I want to find its magnitude, what do we do? How do we find magnitude of AB? Minus 3 square plus 4 square. Then you can get an answer. Because it's always the component plus the component. You square that, add up, and then you take the square root. Everybody clear? Okay, now, how would I get this column vector C? You must start from the initial point. You see the arrow point this way, that means this is the initial point. Okay, so how? 1, 2, 1, 2. So how? Negative 2, negative 2. Agree? Okay? Now, how about DE? Do you get 5, 0? Can you see it's 5, 0? Yeah? How about F? 0, 1. Negative 3. Can you see it's 0, negative 3? Because I start here, I didn't move left or right, but I go down 3 straight away. Can you see it? Now, I want to highlight to you something that you must take note and you must know, okay? Don't just look at the thing. Now, if I have a combination of x, y, the magnitude, of course, I'm going to apply this formula, right? Okay, but can you see that if it's like that, if for 0, the magnitude is just this one? Can you see? You square 5, then you square root, then isn't it 5? Even for this, it's negative 3, but the magnitude is 3, no? Can you see that? Because the length is 3, no? This negative just gives you the direction that is moving downwards. Everybody clear? So when you have a 0 somewhere, there's no need to go and use this. You just look at it, you know already. Understand what I'm saying? But of course, in exam condition, right, some people are very confused, okay? You want to apply also can, but when you apply 0, so you give it the same answer, understand? Everybody clear? Okay? Okay, Alright, good. So, let me just go through again. What do you mean by equal vectors? Okay, I want you to look at the next page, this particular page. The next page. What do you mean by equal vectors? So, need to discuss effects. I discuss with you, okay? Equal vectors means they must have the same direction and the same magnitude. Now, if you look at this, all of you look up. I just want to find out something. Can you see vector A? It's actually 1, 2, then 1, 2, 3, 4, right? It's actually 2, 4, agree? Now, can you see that vector B, 1, 2, 1, 2, 3, 4, is also 2, 4? That means vector A and vector B are the same. They are equal vectors. Okay? Now, then I want you to look at C. Can you give me the column vector of C? 1, 2, 1, 2, 3, 4. This time what happened? Negative 2, negative 4. You agree with what I'm talking about? Can you see it's negative 2, negative 4? Because C originates from here. So 1, 2, 1, 2, 3, 4. Then I reach the ending. Okay. Now, can you see that they are of the same magnitude? But the direction is different. It's opposite direction. Can you see what I'm talking about? Now, if they are parallel and of the same length and opposite direction, that means one is the negative of the other. Okay, for example, we know A is 2, 4, right? C is actually negative A. Now, once you put negative 4, you topalic, you reverse direction. Just like Uno, you put reverse direction. So actually it's negative 2, 4. You put a negative outside. So can you see when I use matrices are bringing this down. Can you see it's exactly here? Now I can also say A is the reverse of C, right? So when I put a negative here, it becomes 2, 4. Can you see? Understand? This is what we mean by equal vectors. Okay? Some of them are equal, but the direction is different. Understand? You get what I'm talking about? And once you put a negative, means it moves the other direction. Everybody clear? Okay, now let's look at D. What is the column vector for D? 2 and what? Negative 4. The magnitude will be the same, agree? That means the length will be the same, but it's totally different because the direction is the other way. It's in another direction. Now, what I want to say is this E. Now, can you see that it's part of B or part of A? But it's only half the length, right? Do you agree that E will be just half A? So it will be actually half of A, which is 2, 4, which is what? 1, 2, right? Then we check, is it 1, 2? 1, 2. Now, you see? It will follow. It will follow. Okay. If this is E, right? If I want to write A in terms of E, what would it be? A will be 2 times E, right? Correct. 2 times E, right? Correct. But E will be what? Half A, right? Can you see what I'm talking about here? Yes or no, class? Okay, so repeat, equal vectors. Let's take a look at page 168. Okay? Now, in summary, A, B, and E, okay, have the same or opposite direction. We say that the vectors are parallel in general. Now, all these are parallel. Okay? But these are also parallel, no? But just that this one is in the opposite direction. Everybody clear? Okay? Alright, now let's take a look again. A and B have the same magnitude and direction. Okay? We say that the two vectors are equal and we write A equals to B. A and C have the same magnitude but opposite direction. C is called the negative of vector A. Okay, to see the negative part there. And A and E have different magnitudes but the same direction. We will learn more about this in section 5.4, but I already told you what it means. It's 2 times the thing. Okay? Now, for equal vectors in column vector form, PQ equals to RS only when the two are totally the same. Just like when we have equal matrices, all the elements must be the same. Everybody clear? Everybody clear? Okay, I'll give you 30 seconds, you look through this again. Okay. Alright. Now I'm just going to use the grid. I don't want to see the axis. There's no need to draw this axis. Understand? Okay, no need to draw the XY axis. Just push it, okay? Okay, let's take a look at the word example. Because later we are going to draw it. Especially when there's addition and subtraction, you must know how to draw. Okay? Alright, let's take a look at work example 1 on page 169. On the 1 by 1, 1 unit by 1 unit square grid below, draw the column vector 2, negative 3. And what? And negative 4, 5. Okay, I'll just use the grid so that I don't have to draw, okay? There's no need to draw the XY axis, as we say already. Okay, now all of you go. I start somewhere. As if I just point somewhere. Now, first vector is 2. So 1, 2, right? Then go down 3, right? 1, 2, 3. So this is the end point. So it goes like that. This is your 2, negative 3. Must draw the direction. Everybody clear? Now, next. Negative 4, 5. I start somewhere. Negative 4. 1, 2, 3, 4, right? Then how? I go up 5. 1, 2, 3, 4, 5. So it will be like this. Can you see what I'm talking about? Yes or no? Now, can you see that even if I start here, I draw, it will be the same. It doesn't matter one. Because I just want the vector only. I don't need to have the position with respect to the origin. You understand? When it's position vector, then we need to have with respect to the origin. Everybody clear? Okay? Alright, Alright. So, are we clear so far? Are we clear so far? Okay, then we look at practice now 1. All of you look at practice now 1. I don't need you to draw, you don't draw, okay? You just listen to me, can already, Okay. You look at this square grid, I'm going to put a square grid here, so that I don't have to draw until fainted. Okay. Those who don't understand, right? Practice now 1 is only a good one for you to look at it. Let's look at practice now 1. First one. Draw the following column vectors on the square grid provided in work example 1. Now, I already give you, you don't draw on your paper, the paper is for the homework, okay? 4, -6. First one. I start somewhere, right? I start somewhere, right? Okay, let's say I start here. What do I do? Move what? 4. 1, 2, 3, 4. Then, -6. 1, 2, 3, 4, 5, 6. So, it will be like this. Can see it now? Clear now? Clear now? Clearer now? Okay. Next one. What do they want? -2, 3. Okay, I start somewhere. Here. Where's -2? Yes. 1, 2, 1, 2, 3. So, my vector will go this way. Remember the direction. Everybody okay? Last 2, 4.50. That means I start somewhere. 1, 2, 3, 4, 4.5. 0, that means I don't move up, don't move down. And actually it's a horizontal vector. Okay, now this one I can get the magnitude straight away. What's the magnitude? Just 4.5 now. Okay. Now from here, actually I can tell you how the magnitude formula comes about. Can you see I can draw a right angle triangle? Can you see is this square plus this square is this square, Pythagoras theorem? That's how the formula comes about. It's not by magic. It's actually by Pythagoras theorem. But in the exam, of course, we're going to draw this. It's wasting our time. We know it, can we? Everybody okay? Alright, the last vector that I have is negative of 0, 1. Negative of 0, 1. What does it mean? 0? Negative 1, right? Okay? So, I will go this way. Don't move, then I move down one space. So, like that only. Understand what I'm talking about? Yes or no? Everybody okay? Everybody okay? Now, this is the first vector, which is 4, -6. Am I right? Now, I want to ask, what if I reverse direction? What would it be? Yes, -4 and 6. Agree? Because you see, 1, 2, 3, 4, -4, this direction, and then 6 upwards. Can you see it? It's parallel, but it's in the opposite direction. Everybody clear? Okay. They can only be equal when they are parallel and in the same direction and have the same magnitude. Everybody okay? Alright, good. So, I hope I have made myself very clear here. Are you okay? Are you okay? Now, plus, I know you're tired. I'm actually extremely tired also. Okay? So, can we look at example 2 now? I'll show you example 2. Okay, example 2. I will show you on the board, so that it's easier. Okay? Alright, all of you look at the board now. This type is not as simple as you think. It looks very simple, okay? But it's not as simple as you think. Alright? Okay, I'm not going to off this slide anymore. 2 column vectors A and B are such that A is x minus 2, 3 minus y, and B is 4 minus x, y minus 6. Now, can you see I always remember to put my tweezer? Understand? You must remember to put the tweezer because it's a vector. Okay? Now, the question says, if A is equals to B, 1, find the value of x and y. If a is equals to b, that means all the elements must be the same, right? That means I will have x minus 2 equals to 4 minus x, and 3 minus y equals to y minus 6, right? So I will solve. 2x equals to 6, x equals to 3. Negative 2y equals to negative 9. Y is actually 4.5. Can you see it? Can you see what I'm talking about here? So x is 3, y is 4.5. Everybody okay? First part. Now actually this one is from indices, not indices, matrices. Correct? Okay, next one. Write down the negative of A as a column vector. So of course, we got to go and find out A first. A is 3 minus 2, 3 minus 4.5. Am I right? So what does it give me? 1 and what? 3 minus 2 is 1, right? 3 minus 4.5 is what? I don't know what. I don't know. What's 3 minus 4.5? I don't know the answer. You must know. You don't know, you let it get up. Huh? Quiet then, wait. Negative 1.5. Very good. Is this the answer we want? What does the question say? The negative of A, right? Which means it will be the negative of this guy. Which means it's what? Negative 1 and 1.5. Okay, now of course in exam no need to write so hard, okay? Just put negative 1 part, this one straight away, I know already. You know it's so simple, you just don't plan already. Alright, just flip the sign, that's all. Everybody okay? Alright, so it's 1 and negative 1.5. So you negative it is negative 1, 1.5. Everybody okay? Everybody okay? Now, can you see this part here now? Show that the magnitude of A is equal to magnitude of B is 13 over 4. Now they already tell you A is equals to B. That means you either take this one or this one can already. You don't need to show both. Correct? Am I right to say that? Because you got this 3 and this 4.5 from these two. Now you look, if I put 3 here, is 1, negative 1.5. Am I right? If I put 3 here, is also 1. Correct? 4.5 minus 6 is also negative 1.5. It's the same. Correct? That's why they are equal. So you don't say, oh, go and find the magnitude. They are the same magnitude. Understand? Clear or not clear? Okay? Alright, now, so how do we get and show that the magnitude is this? Okay, let's show. So if I want to find the magnitude of A, now because if you want to have the column vector and you want to find the magnitude, right, you can write like that. Understand? The magnitude of this. Understand? So this will be square root of something square plus something square. What's the first something? 1. This is a negative 3 over 2, am I right? Negative 1.5 is negative 3 over 2 now. Okay? So this is a 1 plus 9 over 4, right? Okay? So this will be square root 13 over 4, right? Can you see shown? Yeah? If I want to simplify this further, we are A math students, so it's what? Also can, right? Right? But because the question say like that, don't give up, don't give up, just do like this. Understand? Okay? Now, next, if A mod A, if the magnitude of A is equal to magnitude of B, express Y in terms of X. Okay? Now, they didn't say A is equal to B. Part B is independent of A. Understand? Or part 1. So if magnitude of A is equal to magnitude of B, express Y in terms of X. Now, what is it when we say express Y in terms of X? Make Y the subject, right? Y is alone. So, magnitude of A will be what? Correct. Everybody okay? Okay. What about the magnitude of B? magnitudes are equal, I will equate these two, right? Correct. Now I take square root on both sides. Right? Agree, class? Okay, I'm not going to do it. Okay, so you look at this long working on page 171. Can you see they simplify, blah blah, expand, blah blah, then they get this. Okay, can or not? Can or not? Can see how? They took y alone, then all the things they shift it to the other side. Okay? Now, then we look at the last part of the question. What did they ask? Okay, what do they ask? Explain why A may not be equal to B. Now, they may have the same magnitude, but they may not have the same direction. You agree with what I'm saying? Because A can be like this. If, of course, B is like this, same length, same direction, of course they are equal. But if, let's say, B is like this, it also same magnitude, but the direction is different, so they are not equal. Everybody clear? So the answer is, A may not be equal to B because only their magnitudes are equal, but they may have different directions. So you cannot assume that when magnitude is the same, they are the same. No. You must consider the direction as well. Everybody clear with my explanation? Okay, Alright. So that will be your example 2. Can I move on to example 3? And that will be your last example. Okay? Look at example 3. This one. Okay. O levels, they like to give you like that, ask you to draw. Paper 1 especially. Okay? Let's take a look here. I want everybody to look up. Don't look at the textbook. Let's look at the board. Okay. The figure below shows the positions of points P, A, and B, where AB is 3, 1. Now you look at AB. 1, 2, 3, 1. Can you see? It's correct, the column vector. Okay. Now, then what did the question say? Express PB as a column vector. Okay. What we do is that we draw like that. They want PB, so must be this direction, correct? So can someone tell me PB is what column vector? You count? 2? Yes. 2, -3. Can everybody get it? It's very simple. 2, -3. Everybody okay? Now part 2. Q is a point such that ABQP is a parallelogram. Express BQ as a column vector. Now ABQP. When you label, you must go one round. So ABQ must be somewhere here. Then P, right? Correct. Okay. Can I clean out this one because it will confuse you? Clean out this one. It must be a parallelogram. So like this. That means I will have 1, 1, 2, 3, 4. So 1, 1, 2, 3, 4. So Q must be somewhere here so that you can get the parallelogram, right? Okay? You can do counting also, it doesn't matter. Everybody clear with what I'm saying? You can do counting and just draw it and get a parallelogram. Everybody clear? Okay, then what did the question want? I want to know the question. Part 2, what did they say? Express what? BQ as a column vector. Okay, all of you look. BQ is like that. So what's BQ? Huh? 1, 4, right? Can you see it's 1, 4 straight away? Okay, so BQ is 1, 4. Now next part, part 3. R is a point such that ABPR is a parallelogram. Express PR as a column vector. Now, I'm going to clean up again, because if not, it's going to confuse people again. Now, it's ABPR. It's a parallelogram. I told you it must go one round, right? So, ABP, that means R must be somewhere here already. Agree, class? Okay, now I join this. Okay? Do you agree this will give you a parallelogram? Can you see? So this will be my R, right? Can you see? Okay, you can do counting. You can get the answer. Okay? So, what will happen here? What did the question say? Ask for what? What did they ask for? Part 3. PR. Can all of you look at PR? PR is like that. What's the column vector? -3, -1, right? Can you see it? Okay, I want to point out something here. Do you agree that AB and PR, they are actually parallel? But they are in what? Opposite direction. Now, can you tell me the magnitude of AB? 3, 1. What's the magnitude of PR? -3? -1, right? Can you see it's the opposite? Can you see it's the opposite? Okay, what if I don't want PR, I want RP? Then it will be 3, 1. Can you see? Because they are parallel and opposite until they are the same. Everybody clear? Why am I saying this? Because at the back got a lot of this kind. You must recognize whether it's parallel or not. Or is it in the opposite direction? You must know. You cannot don't know. Understand? Okay? Now last part. Okay? Do the two vectors PQ and PR have the same magnitude? Just now I draw, right? BQ is this is your Q, wait. The question says, do the vectors PQ and PR have the same magnitude? Now you count up, can you see 3, 1, 3, 1? They have the same magnitude actually. Can you see? They have the same magnitude because of the same length. But look at the next question, next part of the question. What I mean is PQ equals to PR? The magnitude is the same. But I want to ask, is PR equals to PQ? They are not. The magnitude is the same, but what is different? The direction is different. Everybody clear? Okay, so let's see how they answer. Look at the last part here, at the solution. Okay, the very last part. Okay. PQ and PR have the same magnitude, but PQ is not equals to PR vector because they do not have the same direction. Are we clear now? Are we clear now? You have to establish this, you know. If not, later at 5.3, 5.4, all this you are going to get blurred. Everybody can? Everybody can? Okay, Alright, good. Okay. Next. I need you to write on the content page of your e-maths. Content page of e-maths. Okay, I'm going to start the question together with you. Okay? Today, no need to do the square paper yet because I haven't do addition subtraction. Okay? What's the number on the foolscap on the content page now? Now I write what? 14. I find that I'm the kindest person on earth today. Can you see? I'm very kind today. Okay? Alright. Now, I just want to bring your attention to question number 9. And all of you look at question number 9. There's no need for you to produce a diagram. You just draw on the textbook and then just give me the vector. Do you understand what I'm talking about here? Yes or no? Okay, I'm going to start with question number 1. Find the magnitude of each of the following. 1D. All of you write. I want to find the magnitude of this, that this. I must have like that, right? Correct now. So it will be how many units? Okay, all of you find out for me. It's a straightforward one. How many units? Huh? 13. Straight away. Correct? Okay. You see, I'm very good now. I'll wait each one for you. Let's keep bottom now. Number 4. Can you draw the diagram? Let's look at part A. Find the value of the magnitude of AB. Now, I'm telling you, I don't even need to use the formula. Just now beginning, I told you already, right? If one of them is 0, is there any? No. So what is this? How many units? Just 7. Am I right? Is it that? Just 7 units. Agree, class? Now, let's say in exam you don't know. You put like that. Isn't it 7? Can see it? No waste of time. Everybody clear? Okay. So this is your part B. Next, your part B. Part B, what does it say? Express each of the following as a column vector. DC. DC. Now I want all of you to observe. This is important. Hello? Can you see DC is a parallelogram? It must have the same length and the same direction. Right? Can you see the direction DC? So DC is actually equals to AB. Right? So what is DC? It must be 7, 0. Agree, class? Can you understand what I'm saying? Okay, this is part 1. Part 2. What do they want? DA. They want the vector DA. How about you look up? Now, BC is this one, right? So AD will also be this one, right? So DA is the direction. So I must negative of this a bit. Because it's the other direction. Can you see? Repeat, all of you look. BC is this one, right? So AD will be the same because same direction. But if you want the other way round, it must flip, right? Negative. So what is this? 3, negative 4. Are you all clear? Are you all clear? That's why I say when you see the diagram, and if you look at section 5.5, it won't be so simple. They have a lot of triangles and quadrilaterals superimposed on one another. Understand? It won't be so simple anymore. Okay? Alright, now I want to give my instructions now. Question 7. Can all of you look at question 7? This is exactly the same as the work example 2. Do you understand? You follow the same way of presentation. Okay? And question number 9 is actually the same as my last example, work example 3. So I will leave you to do these 2. Understand? Following the same way. Like for question 9, I say already there's no need to reproduce the diagram. You just sketch on your textbook and write down the answer with you. Everybody clear? Okay, do it now. We shall stop the video.